Alright guys, I'm coming back at you with a second video. It's going to talk about polar roses, but first I guess I should have mentioned in my previous video about distinguishing between a sine polar curve and a cosine polar curve. So here you can see I have a cosine polar curve, and I could turn it into it's a circle right now, but I could turn it into a limicon by changing what the midline is. I could also, if I negate uh, if I do a negative amplitude value, you can see the curve now shifts to the left here. Big picture here is that cosine curves, when I graph them in polar coordinates, will always have symmetry about the x-axis. I should specify polar limicons and polar roses that are based off of cosine. And then sine, here's a sine polar circle. But if I make the amplitude bigger or negative, now you can see that the sine ones are going to be symmetric over the y-axis. And again, if I shift the midline, you can still see it's still got that symmetry about the y-axis. So the same actually holds for the polar curve. Really, the big picture about polar curves is how many petals it has. It's going to be pretty substantial to us when we get into BC next year. But for now, we just really have to memorize what happens if we have an odd number or an even number in front of the theta. So right now you can see here is sine, technically 2.9 sine 3 theta. This number that's in front of the trig function makes the rose petals bigger. If I do a negative, you can see that it just flips it upside down. Still has symmetry about the y-axis because again I'm dealing with a sine wave. Sorry, a sine polar rose. But what's really interesting here is this transition from an odd number to an even number and back and forth for the theta, or the number in front of the theta. So you can see that if I do sine of, or 4 sine 2 theta, we get this flower looking shape, again called a polar rose, and it has 4 petals. And if I switch it up to 3, I love this gradual transition here. It kind of shows why we only get 3, and it's kind of showing the fact that the graph kind of overlaps itself for an odd number. But as soon as I switch back to an even number, the graph doesn't overlap itself. So it's the fact that when I graph from 0 to 2 pi, which is going to be pretty much our standard for polar curves, with an even number of petals, if I switch this to 0 to pi, now we only see half of the curve. But if I switch to an odd number of petals, we see the whole thing, because if I bump it up to 0 to 2 pi, we end up having a repetition, repeated pattern. So that's kind of the interesting thing about the polar curve. So essentially, if we have an odd number of petals, or an odd number in front of theta, we're going to have an odd number of petals, and that exact number, so if n is 5, I'll see 5 petals. If n is 4, I will actually see twice as many petals. I'll actually see 8. And if we switch back to an odd number, 3, we see 3 petals. And so on and so forth. So, that's kind of the big picture there. Identifying the difference between sine and cosine polar curves, polar roses in particular, really has to do with that initial value for cosine. I think about the cosine wave as a function. So let me switch back to cosine here. Let's switch this back. Cosine doesn't go through the origin, right? Cosine starts at its minimum or its maximum. So when theta is 0, cosine is going to be starting at its highest point, which is why with the polar rose, when theta is 0, the graph will be starting at whatever that number is in front. So if I had like 4 cosine theta, 4 cosine 2 theta, you can see right here at 0, it's actually hitting 4. Whereas if I think about the sine polar rose, and if I do 4 sine 2 theta, it's not going to be clear. There we go. You can see that it's not starting at 4. It's actually not going to be hitting, it's going to be hitting 4 at this angle here, which if you could probably guess is pi over 4. I could go through some math to kind of explain why that happens. If I plug in, pi over 4 and then multiply that by 2, I get pi over 2, because 2 pi over 4 is pi over 2, and that's where sine hits its maximum. So that's pretty much the kind of distinguishing factors between sine and cosine. You can see when it's an even number of petals too, the symmetry thing is kind of harder to see because this graph has symmetry over both the x and y axis. So it's hard to see that this could be sine or cosine. So really the distinguishing factor is looking at where it starts. Does it start at its maximum when theta is 0, or does it start at the origin when theta is 0, like this one? So that's kind of the distinguishing feature between sine and cosine. All right, so then the next video I put out either tonight or tomorrow will be about converting between polar coordinates and rectangular coordinates. All right, this one is a little bit shorter. See you guys later.